we are asked to solve for this equation, given that its solutions are in this interval. Without any hesitation, the first step would be to bring everything to one side. So I'm going to take everything to the left. So we have 2 sine alpha tan alpha minus tan alpha. We're going to transpose the 1 to become minus 1 and also transpose the negative 2 sine x to become sine alpha. All right, so we moved these two terms to the left and their signs changed. All right, so now we need to group the terms. When I see 4 terms, I always think of grouping. So the first 2 will go together and the last 2 will go together. All right. So now on the first part, we can see that tan alpha is the common factor. And when it cancels, you are left with this. So here you have 2 sine alpha. Here it cancels to give you minus 1. And you can see that if we rearrange this equation here, we're going to have plus 2 sine alpha minus 1. You can put that in bracket, which equals to 0. Now, if you look, ladies and gents, you still have another common factor of of 2 sine alpha minus 1, and we can take that out. 2 sine alpha minus 1 will be tan alpha minus, plus 1 is equals to 0, right? Now, applying zero product, we can say the first bracket will be 0, or the second bracket will be 0. Then we can see that sine alpha is equals to 1. 2 sine alpha equals to 1, which means sine alpha would be 1 over 2. And then this side, we can see that tan alpha is equals to minus 1. So now, ladies and gentlemen, I am going to firstly deal with sine alpha equals to half. Let's get the reference angle. Shift sine half. That is equals to 30. Therefore, reference angle will be 30 degrees. Remember, reference angle is always positive. Let's get the reference angle for tan. We're going to have O alpha. Okay, this way I must put alpha there. Yes. Alpha equals to shift tan minus 1. Then I get alpha equals to minus 45 degrees. Therefore, reference angle, ref angle will be 45. You always ignore the negative sign for the reference angle. Now, we can see that the sine is positive and the tan is negative. So, for the sine, my solutions are going to be in the first and the second quadrant. For tan, my solutions are going to be in the second and the fourth quadrant, because that's where the tan is negative. So what guides me is the sign here. Tan is giving a negative output. So I know that, okay, if sine is giving a negative output, or not necessarily there, from there, where we're shifting, right? Tan was negative. Also, if you check here on top, tan was negative, sine was positive. So sine is positive in the second and the first quadrant. Tan is negative in the second and the fourth quadrant. Now, solution in the second quadrant would be alpha is equals to 180 minus reference. 180 minus reference is 150. So it's 150 degrees plus k dot 360 degrees, where k is an element of integers. That is in the second quadrant. Sorry about that. In the first quadrant, the solution would just be alpha is equals to the reference angle. The reference angle is always in the first quadrant, then 360 degrees, k elements of integers. All right. And then here we can see that, okay, tan is positive, is negative in the second quadrant. So alpha for the tan, let's do a line here. For tan is going to be 180 minus the reference, which is 135, plus k 360 degrees. You don't need to always show actually that k elements of z. Ne? You can only show it once, right? If you show it there, you don't have to show it on the other ones. And then we're also going to have alpha is equals to, in the fourth quadrant is 360 minus. Ne? So we're going to have 315 because we're going to say 360 minus the reference angle. And then plus k dot 360. All right. Perfect. But we need solutions that are only in between negative 90 and 90, right? So ladies and gents, this is how you're going to do it. Ne? You take your calculator. I'm going to take mine too. You type this thing. So let's type it together. We're going to say 150 plus 360, open a bracket for the k. Ne? And then we're going to put random values of k there. So we're going to say x elements. And then we do this. So for example, I can put k minus 2. It gives me negative 720. Doesn't work. So I'll say minus 1. I keep on increasing by 1. Ne? It gives me 210, which is outside the interval. Negative 210. Then I go to 0. 0 gives me 150. Doesn't work. Okay, the 150 doesn't work because it goes outside the intervals with all the solutions. Now let us do the same for this one. We're going to say 30 plus 360. Open a bracket. We're going to say negative. I like starting at negative 3. Ne? It gives me negative 1050, which is out. Then negative 2, 690, negative 690. Then we do negative 1, which gives us negative 330. Then we do 0, which gives us 30. And 30 is in the interval between negative 90 and 90. So we take that one. And then you do 1, which is outside. So you are done with that. Then you replace the 30 with 135. And then you go back there. You replace the k again. So you have 135 plus 1 plus 3. Oh, sorry guys, for tan, this is tan, right? So for tan, we use 180 degrees, because tan is periodic every 180 degrees. Sorry about that. So you're going to have 135 plus 180 times k. So I'm going to start at negative 3. It gives me negative something that is outside. Then I do negative 2. Gives me negative something that is outside. Then I do negative 1, which gives me something that is outside. And then I'm going to do... oh, wait, guys. Wait. Here I made a mistake. So it's going to be 135 plus 180, open a bracket. Negative 2 doesn't work. Let's check negative 1. Negative 1 works, gives us negative 45 degrees, right? Then negative 2 doesn't work. And then let's do 0. 0 also doesn't work. So that is our solution for 135. Now we're going to go to 315 plus 180, negative 3 outside, negative 2 is negative 45, of which we already have. Negative 1 is outside. So it means those are our only solution. And that's it with this question, ladies and gents. Thank you very much.